So last class we are started the double bottom construction of the ship. So we'll continue with that. So double bottom construction. So what is how it is made? The double bottom. It is the strong girders or the beam structure we have. It means we have the beam as well as the girder we do have. So uh, we have the longitudinal girders and beams. We have the beam structure. It is like we have the transverse structure that is like a beam. So girder, actually girder, what is the difference between the girder and beam? Girder, it can take a larger load and beam can take comparatively lower load. Suppose we see a girder. So if we see a girder, like we have longitudinally placed a girder, for an example, like this. So this takes much more load than the, suppose we have number of beams here. So the double bottom construction will be combination of that. We have the girder structure, we have the beam structure, we have the floors and all. So this girder will take, and then finally what will happen, it will have a cross section, and means it will have a, if you see the cross section, it will be like that. So it will have a structure like this, cross section, and there will be internals in it. So this is the uh, structure, and this gives us a strength in the ship structure. Now there are different type of strength it has got, like the it is, and also it is we have seen that it is the bottom, it is the bottom shell, and there is upper that is the tank top. So it is a two layer of plating you have, whereas bottom is the shell plating and the top is the your tank top or the inner bottom, we call it. Now this gives us a strength, the double bottom structure. So this strength is gives us a secondary hull bending strength, but it gives very little primary hull bending and strength. Whereas the secondary hull bending and strength, it gives you the major strength. It gives you, it does not give primary strength, or the, it gives very little. Now, what is actually the primary and secondary? So let us see this. So the primary and secondary. The primary hull loading, what we talk about, that strength and the bending. So it is, we are considering the ship as a beam. That is the horizontal, means the longitudinal way, complete ship structure we can consider as a single beam. And once we consider as a single beam, then what will happen? There are different loading. There are forces. There are ship has got weight. That hull has got weight. That weight is it comprises the longitudinally completely, and as well as there are machinery. In the machinery also it has got masses, so it has got weight. So that has to also consider. So these weights are downward, it is in downward direction. Now also ship has got the bouncy forces, which is upward direction. And if you deduct that, because one is downward direction, that is the weight, and one is upward direction, that is the bouncy force, because it has displaced the water, underwater portion of the ship. So this, if you deduct these two, then we'll get a resultant force. That force we need to consider, because that force will cause, it has to be, ship has to be strength to withstand that force, as well as there will be bending moment because of that force, and that also has to be considered. And in addition to that, what will happen? There will be wave force. Wave water level will not be same due to the wave. So if we consider that the ship is the wave force, due to the wave force, there will be two things. That is, one is sagging and hogging. Now suppose the, if you see this diagram. So in this diagram, in the wave, suppose we consider the wave uh, is the length of the wave is the length of the ship. That can be the worst case it can happen. When the design calculation is done, it calculates that way. What's condition we calculate. Then if it is less than that, suppose it's not length of the wave is not the length of the ship, then it will cause less stress, less bending moment. So it is, we have already calculated the maximum bending moment and the stress. So in this condition, what will happen? Suppose the wave a length is the length of the ship exactly. Then what will happen if the crest is at the center and the height means the maximum height is at the end? Then what will happen? This end will be supported because the bouncy force will be high at the end. Whereas the middle portion, that is the mid-shape portion, the bouncy force will be less because the less quantity of oil will be, means the water will be, uh, less quantity of water in this case will be the, like the wave will be like this. So here the displaced water will be less. So the bouncy force will be less. So what will happen? It will be like a beam. We have considered the complete ship as a single beam. In that case, this point, the support will be higher. It will be supported at the end. And what will happen? There will be a sagging. This is sagging. And due to the sagging, what will happen? This side, this side will be under tensile and this side will be under compression. Now, it can have another situation where the trough is at the side. It means it will be like this. So in that case, what will happen? At the center, it will be supported. It means that it will have the hogging. In hogging condition, because it will be bouncy force at this point will be higher. So this side will be in, this side will be in the compression and this side will be in the our tensile. So it will have a cyclic effect. So primary loading, bending, the strength is this one. And apart from this, ship will carry cargo. That cargo load also will cause that primary loading. It means the ship has to withstand that forces also, that condition also. So in addition to that, not only hull structure, Hull structure has got a weight, and it has to withstand that. It will be subjected to the primary loading and bending, as well as the machinery. And then because of the machinery, there will be a bending, as well as that has strength has to be withstand that. And cargo also, when it is loaded, that also has to be considered. So these all, when you consider that, we call it primary loading. So this is calculated this way. Like, this is due to the hull, machinery, hull weight, because we have considered a single beam and the cargo load. And sagging and hogging, what I have just told, it will be like that. It will be subjected to the maximum stress and the bending moment. And what we have seen, the maximum bending moment will be at the center of the ship. And as we move away from the center to the forward or the aft, the bending moment will be reduced. And at the end, bending moment will be zero, because it will be at the midship. Midship will be the peak. In naval architecture, numerical part, it is in your syllabus, will calculate, and it will numerically and mathematically you can see that where the maximum bending moment it will be. It will be maximum only in that condition. Because of the wave, it will be at the center, and that is the worst condition we have considered. So the center portion will be maximum. The strength is required. That is the reason center portion is strength is the calculation is maximum, and it is strengthened max. So this how do we as we move to our bow or the stern, it will be very minor. It means it will keep on reducing, and it will be minor, and at the end it will be zero. And we calculate this strength, primary strength. How do we calculate? It is the same. We calculate the moment of inertia. So BH cube by 12, because we have considered the ship as a single beam. So complete shape we calculate as a single beam, and we can calculate in this form. By using this formula, we can calculate what is the bending moment, that the inertia effect it has got. It means inertia effect means it is giving the resistance to that. So how much stress and bending moment it can withstand. So, but what is secondary strength, secondary bending moment? So secondary is the bending moment. It means the primary one, we have the bulkheads. So bulkheads gives us the primary strength. That is, we have seen the ship has got number of bulkheads along the length. So that these bulkheads gives us the primary strength. It is complete length. Now in between two bulkheads there are structures. So that structure is the second, gives the secondary strength, and it registers the secondary bending moment locally. So in between two bulkheads, for an example, all the structure what we have, that gives us the secondary, that is considered, we consider it as a secondary hull bending and the strength, how much it will be. So, but what is there actually, the forces in that condition, the forces in that condition for the secondary also, that space also it will displace over water when it is floating, and that will give you a bouncy force, and that it has to strengthen such a way so that it does not collapse. So these are the local strength we calculate, that is the secondary. And if you see the double bottom structure is a part of the structure. It means it is the secondary calculation. We do the side, bottom, and deck, and which is subjected to the uh, displaced water. That is the bouncy force is directly subjected to, and maximum deck is not bouncy force, but stress is calculated. It is a scheme of the structure we calculate. So In this case, what will happen? These are the shorter section, and this shorter section in between two bulkheads, as I told you. So this will indicate it as a beam. It means we'll consider it as a beam. It means the internal shear force, internal moment, bending moment, and due to the rotation of the deflection, there will be of the beam. It will consider as a beam is a local, the girder as a local. So how what all things forces will be subjected to that, that we consider as a secondary strength and bending moment. So in this case, what will happen? It is not primary loading. Primary loading is, we have seen that it is a complete ship we have considered as a single height. Whereas here we have just a little portion of the double bottom, for an example, that we are considering as a secondary load. So this is the, it is like a composite panel we consider, like on the ship side there will be a curved structure, there will be bent. It means it will not be like on the ship structure. What will happen at the side? There is a curve. In the double bottom, this is the double bottom. Suppose there are a framing system. It means this, suppose a bracket is here. So this bracket will be having a curve here. So these all is considered, that is the called complex or complex composite panel. It means it will not be a straight structure. It means not necessary that it will be only a straight line. If you have a section, it is a, whether it is I, whether it is flat, whether it is T, but there can be curves also. So these become a complex composite panel, which is supporting at the side. It means the secondary only it is supporting at the side. So that we consider, because your double bottom tank will be at the, it is supporting the bottom shell, and you have inner shell. So bottom part it is supporting, it means it is supporting the skin basically. And that is the reason for the secondary, the side shell, bottom and deck. Deck also it is giving a outer support. So that we consider as a secondary hull, loading and bending. In that case, what will happen? It means the it will be a local total force when you calculate. It will be saying that there will be some weight which is downward direction, as well as there is the displaced water in that one area and how much it will be displaced, and then what will be the force, resultant force, and accordingly we can find out the bending moment of in that area. And in this case, it will be inward direction, because double bottom will be subjected to the inward direction force. Bending will be inward direction, because outside there will be water which will try to collapse internally. So that's the reason the bending moment it will be inward between the bulkheads. Two bulkheads between what the double bottom structure is there, that will be subjected to inward bending moment. So this is the way we calculate the secondary uh, strength as well as the secondary bending moment. That is the reason what is written there, that we have the structure, that is the double bottom structure, subjected to the uh, secondary loading, then the primary loading. Primary loading, it will be very, very less compared to the secondary. Major it is secondary loading and bending. So this is the secondary and primary bending moment. Now, if we see the uh, double bottom structure, this is a bulk carrier. It is shown the structure of a bulk carrier. Bulk carrier, if you see the double bottom, this is the half is it is shown. It means the only one side of the center line it is shown. So in this case, what will happen? What we can see in this diagram? In this diagram, we see that this is the center girder, and this is the bottom shell, and then at the center area we have the kill plate, and then this what we see this one, So this, the straight plate, what we have seen, it is actually longitudinal. It is not a normal plate. It is a longitudinal, which is uh, longitudinally placed. That is 4.5. Because, for an example, suppose we consider this side is forward and this side is aft. It means it is placed horizontally. It means it is placed longitudinally. That's why it is called. What is the name of this stiffener? We call it the bottom shell longitudinal, because it is supporting the bottom shell. That is the reason bottom shell, and it will be continuous. If you see this, it is continuous, whereas the floor plates, this is the floor plate, this is the solid floor. Solid floor have a cut. Uh, Previously, I had already explained, it means the solid floor will have a cut to pass through this longitudinal. Longitudinal will be uh, continuously, it will be joined together, one section of longitudinal, next one will be joined, and it will pass through continuously. Whereas the access is made by cutting the small portion on the solid floor so that longitudinal can pass. And what is this plates? Like this is the center girder, these are the side girder. So in the side girder, it is also placed because if the width is large, depending on how much is the width, if the width is large, then many vessel we make nowadays that is flat bottom, because it gives us the improve the efficiency of the ship. So that flat bottom, if you have, then the uh, bottom structure, it will be, width will be increased at the bottom, and once the width is increased, there will be number of side girder it will be placed. And then we have the solid floor. These all are the solid floor, what we can see here. And this solid floor, as we all, as already I have told you in previous classes, that the solid floor, it can be having the lightning hole, or the with lightning hole it can have, but it is solid floor. It is called solid floor, and the bracket floor is not the solid floor. We'll see the bracket floor now. What we have, this solid floor suppose does not have any hole, that is the lightning hole, then we call it watertight bulkhead. It means watertight floor we have. It is also solid floor, but there is no hole, so we can make a different compartment on the ship. And as we move this direction, then there is a hopper. This hopper is provided for the or bulk carrier, because bulk carrier, uh, uh, if we load, then uh, once you are loading, that time this space will not be filled, because it will make loading like this. So this space will not be filled if we make it like this. So this corner will not be filled. So instead of, since we cannot use this side, so we make a hopper. So it makes easier for cargo discharging time. During the discharging time, or what will happen, this cargo will slide down, and then it can be easily discharged from here, this portion or this portion. So that is the reason we put a hopper tank at the bottom. So this is also can be part of the your double bottom structure, and it can be also a separate tank. Both, if it is a separate tank, then up to this is the double bottom tank, and we call it the side, this portion we call it hopper tanks, the bottom hopper tanks at the bottom. So this is the basic structure, and this is the tank top, and this tank top is underneath, has to be supported. How it is supported? This is the longitudinal we have. Similarly, we have the bottom longitudinal, that is the bottom shell longitudinal. This is the tank top longitudinal, or the inner bottom longitudinal. So because tank top and the inner bottom, it is the same thing we call it, because this is the bottom, this is the inner bottom. It's like a double hull, double bottom structure. That's the reason. It means we have one fail, another will protect. because water will not come to the cargo hold, or is the ship will not sink. Still, the ship stability will be maintained. And these are the stiffeners we put, because these plates, any plates, it has to be strengthened, because plate will become buckled. So to avoid that, to become the strength, give the strength, we have this stiffness along the lengthwise, because girder is on the lengthwise. So forward and aft it is placed. In between we have the stiffness to give the strength of the girder, center girder or the side girder. Even side girder will also have the similar type of support. And also we have seen that this is the solid floor. In the solid floor, the longitudinals are passing. At the bottom is bottom longitudinal, and the top is the tank top longitudinal. So in between, it means this longitudinal, the strength is taking. It means what will happen? This longitudinal has to, this plate, the solid floor, should take that strength in this area. So what we did, we put a strout, that is exactly same type of stiffener we put as a strout. That is, this is the stiffener we put, and this is the solid floor. So our, and here the top longitudinal, that is the tank top longitudinal, and one longitudinal for the your bottom shell longitudinal is passing through, and you have this solid floor, and it has to be supported. In between we put the stroud, that is the stiffener, exactly what we can see here on the center girder. Similar type of stiffener we do. And this corrugated bulkhead we have already finished. That is, this is the stools, lower stool. In the lower stool, tank top, it is welded, and this is the void space between the inside the lower stool. And we need to make it, this is watertight structure. We need to make bottom also watertight structure. That's why sometime even this and this are watertight. Sometime at the center, in way of exactly at the center line of this, there will be a watertight floor that will not have any hole. So this will make one compartment, other side will make another compartment. And this is the weight. It means this is a heavy structure. So these are the frames. These frames, if you compare the frame and this structure is much heavier than this. So we call it wave frame. And this is the ship side frames. It is only a plate, and it can have the face plate. And this structure is till now, what you have seen in this diagram. Any question? I have explained the double bottom portion, because this is the chapter of double bottom portion. I have not gone to TST and this upper stool, side shell, framing and all. It is there in your syllabus. It will come later on. So any question till now on this diagram? You want to ask any question on this diagram? Okay, if no question, then let me proceed to next slide. So now this tank top, for an example for the bulk carrier. How do you discharge the cargo? To use the grab. Now once the grab is coming and it is hitting, number one it is hitting, and then it is grabbing the cargo. Once it is grabbing the cargo, grab, what happens? There will be a frictional force between the grab and the this tank top, because once we have the grab, once it is coming down, then what will happen? So this will come down like this, and after that what will happen? These two, this portion will come together to grab the, and when it is touching here on the tank top, this is the tank top for an example. So this is tank top. So once it is touching that, after that to grab it, it has to have a frictional force. This has to come closer and then remove the cargo. So in that case, what will happen? There will be wear down of the tank top. So that how will you protect that? We cannot, it will be there. We cannot make it that there will not be any frictional force, because frictional force will always be there. In that case, only option what we do, we add some additional thickness. If we add some additional thickness, so it will get worn out. We know the life of the shape, so it will resist to that. It will get worn out slowly, but it will still, the strength requirement will maintain, because the strength requirement will not be less. So because we have given some additional strength by uh, adding some thickness of the material. It means we have given some mass of the extra mass of the material. So this is the reason we have the extra thickness on the tank top. Tank top part we have the extra thickness. It means we'll increase the thickness, that is the scantling. Scantling means the dimension. It means thickness we are increasing means the dimension. Scantling you will be using most of the cases, because the classification society, this terminology, it is being used in their rules. So we always, when you will be dealing with the surveyor, they will mention scantling. The scantling will mean that dimension. So then the double bottom structure, uh, we have we need to have the access. Because why the access is provided? Because we need to do the maintenance, we need to do the inspection. For inspection, maintenance, we need to have the access. And how will you make access? It means there has to be manual. It means who will do the inspection or maintenance? It is the man has to enter into the space. So that is the reason it is called manual, and manual has to be provided. And manual, where it is provided for the double bottom tank, it is on top of the tank top, it is provided. But any of the double bottom tank which the manual door is not provided,